Honda. A company that got its start putting engines on bicycles became the biggest engine maker in the world. Today, it makes nearly every kind. Sports cars that have rocked the automotive world. Honda sells about 4 million vehicles globally, making it the 7th largest automaker in the world.
Honda's best-selling model, the Japanese automaker is still slinging a lot of Accords with nearly 161,000 finding homes in the first 6 months of 2017.
Electric cars have been making waves in recent years, but it seems they are not the only option for a cleaner future. There's another type of technology that could change everything, and it is none other than hydrogen fuel cells. Honda, a leading name in the automobile industry, has recently revealed their bold plan. They want to release a hydrogen-powered version of their famous CR-V SUV.
CR-V has more space than before, and lots of different ways to help you enjoy that space.
Could this new engine change the way we see the future of cars? To find out, join us as we reveal Honda's new engine that plans to dominate the entire EV industry. Honda reveals plans for their hydrogen-powered cars. Back in 2015, Honda became a trending topic for car lovers after revealing the Clarity fuel cell at the Tokyo Motor Show. This car was not like regular electric or gasoline-powered vehicles. It used hydrogen to create energy, offering a driving range that amazed many. By 2016, the Clarity FCV made history as the first hydrogen-powered sedan available for purchase in Japan. It was proof of Honda's commitment to innovation. The Clarity was special because it wasn't just a regular car with a hydrogen engine. Honda designed it from scratch to run on hydrogen. It had advanced features like wave flow technology, making it more efficient and powerful.
Things we loved? Well, the fuel efficiency for one. Over our 25,000 miles, we averaged nearly 88 miles per gallon.
But even with all this, the Clarity faced huge problems, which would end up leading to it being discontinued. But Honda won't be stopped by this setback as they recently announced that their plans on a new hydrogen-powered CR-V SUV is finally underway. But what were the issues faced by the Clarity FCV, and has Honda overcome these issues with their CR-V SUV? Stay tuned to find out. The Clarity released by Honda, although built from scratch to run on hydrogen, had its benefits and major issues. It was designed to be a clean energy car that didn't rely on gasoline or traditional electric batteries. One of its key benefits was its ability to carry 5 people comfortably, which was an advantage over other hydrogen-powered cars at the time. This made it practical for families and groups, setting it apart from smaller and less spacious hydrogen vehicles. Honda added special features to the Clarity, making it stand out. It had smaller, more efficient fuel cells that provided more power while taking up less space. This innovative design made the Clarity one of the most advanced hydrogen cars of its time. The car could drive up to 360 miles on a full tank of hydrogen.
Honda Clarity, an advanced technology vehicle that can run on pure electric and an efficient hybrid system, also known as a plug-in hybrid.
This driving range was impressive and even better than some electric cars available then. It proved that hydrogen-powered cars could compete in terms of performance and convenience, but despite its benefits, the Clarity faced significant problems that led to its discontinuation. The main issue was the lack of hydrogen refueling stations. Unlike electric cars, which can be charged at home or at many charging stations, hydrogen cars need special stations to fill up. These stations were not widely available, especially in many countries. Without enough refueling stations, it was hard for Clarity owners to use their cars for daily travel. Many potential buyers were hesitant to buy the car because they didn't want to worry about where to refuel. Another challenge was the growing popularity of electric cars. As electric vehicle technology improved and charging stations became more common, buyers were drawn to them instead. Electric cars were easier to own and use, which made them more appealing. In contrast, hydrogen cars like the Clarity were seen as complicated and inconvenient. There was also a lack of demand for hydrogen-powered vehicles in general. Many people didn't understand the benefits of hydrogen technology, and governments weren't offering enough support or incentives to encourage its use. Electric cars received more attention and support, leaving hydrogen cars in the shadows. In 2021, Honda decided to stop making the Clarity. Along with it, they also discontinued the battery and plugged in hybrid versions of the car. While the Clarity was an impressive achievement, the world wasn't ready for hydrogen cars to succeed. The Clarity proved that hydrogen technology had great potential. It showed that hydrogen-powered cars could be efficient, spacious, and environmentally friendly, but the lack of infrastructure, competition from electric vehicles, and low demand ultimately led to it being discontinued. Honda hasn't given up on hydrogen, though. They are now working on a hydrogen-powered CR-V SUV, showing their belief in the future of this technology. But will this new CR-V SUV take the world by storm? Let's find out. Honda hydrogen-powered CR-V SUV. Honda has announced its plans to release a new hydrogen-powered version of its popular CR-V SUV this year. This decision comes after years of learning from their previous hydrogen car, the Honda Clarity, which was discontinued in 2021 due to major issues like a lack of hydrogen refueling stations. Since 2021, things have changed for hydrogen fuel cell vehicles, also known as FCVs. There are now more hydrogen refueling stations, and governments are encouraging people to use cleaner vehicles. This has made owning and using a hydrogen car much easier. Honda sees this progress as an opportunity to bring hydrogen technology back with a stronger plan. The new CR-V hydrogen SUV is built using advanced technology developed with General Motors. It has 2 hydrogen tanks located at the back of the car. These tanks store the hydrogen fuel needed to power the vehicle. The car also has a smart power unit placed under the seats. This system helps manage the energy efficiently. Under the hood, the CR-V has a fuel cell system. This system uses hydrogen to create electricity through a chemical reaction. This means the car doesn't need a traditional battery to store power like electric vehicles. Instead, it makes electricity as you drive. Another key feature of the CR-V is its ability to store a large amount of energy. This helps the car travel long distances without needing frequent refueling. When it's time to refuel, the process is quick and simple. It only takes a few minutes to fill up the hydrogen tanks, which is much faster than charging an electric vehicle. The CR-V has a power export function, which is a unique feature that allows the car to provide electricity to homes or devices. It should be noted that Honda's work in hydrogen technology is not new. It started in 1999 with the launch of the Honda FCX, one of the first fuel cell vehicles. At that time, hydrogen cars were rare, and refueling stations were hard to find. Despite these challenges, Honda continued improving its technology.
Engines that Honda built perhaps better than anyone else are losing favor.
Is Honda walking away from one of their most appealing traits?
The Honda Clarity was a step forward in 2016, but it struggled due to some limitations. Learning from these experiences, Honda is determined to make the hydrogen-powered CR-V a success. The company has invested in building more hydrogen stations and is working closely with governments to support clean energy vehicles. They believe that hydrogen cars, along with electric and hybrid vehicles, are essential for reducing emissions and creating a more sustainable future. Remember we mentioned the CR-V hydrogen SUV is set to launch this year? Well, it's starting with North America and Japan. It will first be sold in regions with good access to hydrogen refueling stations, such as California and select areas in Japan. Honda plans to make the cars available to more areas as more stations are built. The automotive world is excited about this new vehicle because it combines the reliability of the CR-V with the benefits of hydrogen technology. The car is expected to offer the same comfort and practicality that the CR-V is known for, along with the advantages of fast refueling and long driving range. Honda's vision goes beyond just making cars. They aim to lead the way in sustainable transportation by developing vehicles that reduce harmful emissions. While electric vehicles are a big part of this plan, Honda believes that hydrogen-powered cars also have a place in the future. With the new CR-V hydrogen SUV, Honda is showing that they are serious about innovation and environmental stewardship. The car represents a major step forward in fuel cell technology and gives us a peek into what the future of transportation could look like. How beneficial will this Honda CR-V SUV be? Keep watching because what comes next will interest you. Benefits and potential setbacks of Honda CR SUV. The Honda CR-V hydrogen-powered SUV brings many benefits to the world of clean transportation. One of the most exciting advantages is its use of hydrogen fuel cells, which produce zero harmful emissions. Instead of releasing carbon dioxide like gasoline cars, the hydrogen CR-V only emits water vapor. This makes it a great choice for people who want to help reduce air pollution and fight climate change. Another benefit of the CR-V hydrogen SUV is its quick refueling time. Unlike electric cars, which can take hours to charge, the CR-V can be refueled in just a few minutes at a hydrogen station. This is very convenient for busy people who don't want to wait long to get back on the road.
Hydrogen fuel cell vehicle. It's the first hydrogen fuel cell vehicle for the mass market consumer audience.
It also makes the car suitable for long trips, as drivers won't need to spend much time refueling. The CR-V is also designed to offer a long driving range. Its hydrogen tanks can store a large amount of energy, allowing the car to travel farther on a single fill-up compared to many electric cars. This helps reduce range anxiety, a common worry for drivers of eco-friendly vehicles. The CR-V provides the comfort of knowing you can go farther without stopping for fuel. In addition to being clean and practical, the CR-V hydrogen SUV is versatile. The unique power export feature that the Honda CR-V SUV has is quite beneficial, because it means that the car can act as a backup power source for homes or other devices. In emergencies, this feature could be extremely useful, providing electricity when other sources are not available. The car also maintains the reliability and spacious design of the CR-V, a model that has been trusted by many drivers for years. Even with these benefits, the CR-V hydrogen SUV may face some setbacks. One major issue is the limited number of hydrogen refueling stations. While the number of stations is growing, they are still not as widely available as gas stations or electric charging points. In some areas, it could be difficult to find a station nearby, which might discourage people from buying the car. Another challenge is the cost of hydrogen technology. Building hydrogen cars and refueling stations is expensive, which could make the CR-V more costly than other vehicles.
The all-new Honda CR-V e-HEV full hybrid variant will also feature Honda Connect and an upgraded Honda Sensing.
Even though prices are expected to go down as the technology improves, some people might still find the initial cost too high. Competition is also a major challenge. Electric cars have become very popular in recent years, and many people are already used to charging their cars at home. The convenience of electric vehicles might make it hard for hydrogen cars like the CR-V to win over customers. The hydrogen SUV may also face issues with public awareness. Many people are not familiar with hydrogen technology and might feel unsure about how it works. Educating the public and building trust in this new type of car will take time and effort. Government policies and incentives could also play a role. While some governments support hydrogen vehicles with tax breaks and funding for refueling stations, others focus more on electric vehicles. Without strong government backing, the CR-V could face difficulties reaching a large audience. Also, hydrogen production itself can be a challenge. Although hydrogen is a clean fuel, the process of producing it is not always environmentally friendly. If hydrogen is made using fossil fuels, it could reduce the overall environmental benefits of the CR-V. Efforts to produce green hydrogen, using renewable energy sources like wind and solar, are necessary to fully realize the car's potential. The Honda CR-V hydrogen SUV has many advantages, including its clean energy, quick refueling, long range, and innovative features. But it also faces challenges like limited infrastructure, high costs, strong competition, and the need for public education and green hydrogen production. How these issues are addressed will play a big role in the future success of this promising vehicle. Ammonia-powered cars face technical challenges that have impeded their progress. One significant obstacle is the combustion characteristics of ammonia. Ammonia has a different combustion profile compared to conventional fuels, requiring modifications to engine designs and fuel systems. It has a lower energy density compared to gasoline or diesel, which means larger volumes of ammonia would be needed to achieve similar performance levels. This poses challenges in terms of packaging and range limitations, as the larger fuel storage tanks would occupy more space and add weight to the vehicle. Additionally, the conversion of existing internal combustion engines to run on ammonia is not a straightforward process. Engine modifications are needed to accommodate the specific requirements of ammonia combustion, such as changes to fuel injectors, combustion chambers, and exhaust systems. These modifications would require significant research and development, as well as testing to ensure the performance, efficiency, and durability of the converted engines. Another factor that has hindered the development of ammonia-powered cars is the availability of alternative technologies. Over the years, other clean energy options, such as electric vehicles, EVs, and hydrogen fuel cell vehicles, have gained prominence and received significant investments. These technologies have been further developed and have seen improvements in terms of infrastructure, battery technology, and overall performance. As a result, the focus and resources have been primarily directed toward these alternatives, leaving ammonia-powered cars with limited attention and investment. Moreover, the production of ammonia itself poses environmental challenges. Currently, the majority of ammonia production relies on fossil fuel-based processes, such as steam methane reforming. This leads to greenhouse gas emissions, contributing to climate change. To fully realize the environmental benefits of ammonia-powered cars, it would be necessary to transition to more sustainable and carbon-neutral methods of ammonia production, such as electrolysis powered by renewable energy sources. However, the development and scaling up of these sustainable production methods are still in progress, adding to the complexity of adopting ammonia as a mainstream fuel. Lastly, the regulatory landscape has also played a role in the slow progress of ammonia-powered cars. Governments and regulatory bodies have primarily focused on promoting electric vehicles and hydrogen fuel cell vehicles as part of their clean transportation strategies. As a result, the regulatory frameworks and incentives have been more favorable towards these technologies, leaving ammonia-powered cars with limited policy support and incentives. But the dream of an ammonia-powered engine taking over the automobile landscape is very possible. Why? Why is ammonia worth the effort? Ammonia engines have a standout feature that sets them apart: high energy density. This means that a significant amount of energy can be stored within a given volume of ammonia. This characteristic is crucial for efficient energy storage and transportation, making ammonia engines particularly well-suited for sectors like transportation and power generation, where effective energy storage and utilization are of utmost importance. One of the compelling advantages of ammonia engines is their reliance on widely available resources. Ammonia can be produced from various elements, such as hydrogen and nitrogen, which are abundant constituents in the Earth's atmosphere. This accessibility underscores the viability of ammonia engines as a sustainable energy solution. By utilizing readily available resources, we not only have the potential to reduce carbon emissions, but also to develop more resilient and flexible energy solutions. What's interesting to note is that ammonia has played pivotal roles in various industrial settings throughout history. For instance, its use in refrigeration during the 19th century revolutionized food preservation and storage. During World War I, ammonia became a vital component in the production of explosives. In the mid-20th century, ammonia drove the growth of the chemical industry, enabling the manufacturing of synthetic fibers and plastics. In the field of agriculture, ammonia-based fertilizers sparked a global revolution in food production. Moreover, ammonia continues to be indispensable in industries such as cleaning products and pharmaceuticals. Toyota's CEO, Koji Sato, envisions a groundbreaking future for ammonia in car engines, with a focus on low CO2 emissions. This vision of ammonia-powered engines opens up possibilities that could potentially revolutionize the automotive industry, and may even challenge the dominance of electric vehicles, EVs. Why is China doubling down on ammonia-powered cars? And how is that connected to growing interest in low CO2 emission engines across the world? China boasts the largest electric vehicle market in the world. However, there is still a strong demand for traditional combustion engine cars. Nevertheless, there are indications that the Chinese government is contemplating a ban on the sale of internal combustion engine vehicles, following a trend similar to the policies implemented in California. This potential development could present a tremendous opportunity for the emergence of ammonia-powered vehicles, which have the potential to provide a low-carbon and cost-effective solution for the Chinese market. Not only would ammonia-powered vehicles reduce China's reliance on oil imports, but they could also significantly decrease air pollution levels in the country. If China becomes a leader in the adoption of ammonia-powered vehicles, it could set an example for the rest of the world. Exploring alternative fuels such as hydrogen, ammonia, and synthetic fuels could breathe new life into combustion engines. These innovative fuel options may even become more affordable to produce than fully electric vehicles in the future, offering a compelling and eco-friendly choice for a broader range of consumers. Moreover, by addressing concerns about convenience, Toyota has established a solid position in the Chinese market by developing customized EVs for this region. The company's strategic approach demonstrates a commitment to meeting diverse consumer preferences. Toyota's exploration of technologies like the ammonia-powered engine aligns with this comprehensive strategy. It will be captivating to witness the progress of this technology and whether it will eventually become commercially available on a global scale. Considering China's evolving automotive landscape, the potential integration of alternative fuel-powered vehicles, such as those utilizing ammonia, adds an exciting dimension to the ongoing transition toward more sustainable transportation options. Ammonia-powered vehicles have the potential to reduce greenhouse gas emissions, decrease oil dependence, and improve air quality not only in China but also beyond its borders. While GAC and Toyota's ammonia engine development efforts are impressive, it is worth noting that they are not the first to explore this area. About a decade ago, the Korean Institute for Energy Research made significant advancements by creating a vehicle called the AMV. This innovative car utilized a mixture of 70% ammonia and 30% gasoline, resulting in a remarkable 70% reduction in carbon emissions. The AMV project aimed to explore the possibility of a fully ammonia-fueled engine, demonstrating the feasibility of this technology. However, it is important to mention that GAC's engine also appears to produce some carbon dioxide. The company was only able to achieve a 90% reduction in carbon emissions, suggesting the use of another fuel source in the engine's design. This hybrid approach could be a practical solution, considering the properties of ammonia, such as its relatively slow flame propagation speed, which can present challenges for engines operating at high RPMs or low loads. By combining ammonia with another fuel, the GAC engine may have effectively overcome these challenges, ensuring smoother and more versatile performance across various driving conditions. This hybrid approach has the potential to enhance the engine's practicality and usability. Numerous projects have approached ammonia-fueled engines from different angles, all highlighting the ongoing efforts to harness ammonia's potential as a cleaner and more sustainable fuel source for combustion engines. As this field continues to develop, further innovations and optimizations will likely contribute to achieving environmentally friendly transportation goals. Ammonia engines have the potential to offer a low-carbon and cost-effective alternative to fossil fuels, reducing reliance on oil imports and improving air pollution levels not only in China, but also globally. Nowadays, vehicles face a plethora of challenges that have an impact on both the environment and the customers who rely on them for their daily transportation needs. When it comes to choosing a vehicle, customers are faced with a multitude of options, each promising convenience, style, and efficiency. However, beneath the attractive exteriors and advanced features, there are significant challenges that affect our relationship with automobiles. One of the most prevalent challenges modern vehicles face is our ongoing dependence on gasoline. For decades, gasoline has powered our cars and propelled us forward, but its impact on the environment is undeniably concerning. When gasoline burns in the internal combustion engines of our vehicles, it releases a multitude of pollutants into the air, contributing significantly to the global environmental crisis we are currently facing. Just picture this. As you drive your car, fueled by gasoline, it emits carbon dioxide, CO2, into the atmosphere. This infamous greenhouse gas traps heat, leading to climate change and unpredictable weather patterns. But that's not the only toll on the environment. Gasoline combustion also releases nitrogen oxides, NOx, and particulate matter, which degrade air quality and pose health risks for humans. Our continued reliance on gasoline not only perpetuates our carbon footprint, but also raises concerns about the long-term sustainability of our transportation choices. In response to these urgent environmental concerns, we are witnessing the remarkable rise of electric vehicles, EVs, as a promising alternative. The appeal of zero-emission driving and a departure from traditional gasoline-powered engines position EVs as an environmentally friendly solution. However, this shift is not without its own set of challenges, particularly in terms of affordability and maintenance. Affordability poses a significant barrier to the widespread adoption of electric vehicles. Despite technological advancements that have gradually reduced the cost of batteries, a crucial component of EVs, the initial price tag of electric vehicles remains higher compared to their gasoline counterparts. This upfront cost can discourage many consumers, even though there is potential for long-term savings on fuel and maintenance. Maintenance adds another layer of complexity to the realm of electric vehicles. The intricate nature of electric drivetrains and battery systems requires specialized knowledge for repairs. Not all local garages are equipped to handle electric vehicle maintenance, leading to increased costs and inconvenience for EV owners. Furthermore, questions loom about the longevity and performance of electric vehicle batteries, raising concerns about the environmental impact of their disposal. While electric vehicles offer a greener alternative, they also bring about their own environmental challenges. Battery production relies on rare and environmentally impactful materials, questioning the overall sustainability of EVs. Additionally, the recycling and disposal of used batteries present challenges, as the infrastructure for handling electric vehicle waste is still in its early stages of development. The growing interest in developing car engines with low CO2 emissions stems from a pressing need to mitigate the adverse effects of climate change and reduce greenhouse gas emissions. This imperative has led to a significant shift in the automotive industry, as manufacturers, policymakers, and consumers alike recognize the urgency of transitioning to more sustainable transportation solutions. One key driver behind the push for low CO2 emissions is the alarming rise in global temperatures and the subsequent impacts on the environment. The burning of fossil fuels, such as gasoline and diesel, releases vast amounts of carbon dioxide into the atmosphere, trapping heat and contributing to the greenhouse effect. This phenomenon has caused a range of detrimental consequences, including rising sea levels, more frequent and severe natural disasters, and the disruption of ecosystems. Developing car engines with low CO2 emissions is thus crucial to limit the exacerbation of these effects and ensure a sustainable future. Additionally, reducing CO2 emissions from car engines is essential for improving air quality and public health. Combustion engines release not only CO2, but also other pollutants such as nitrogen oxides, NOx, particulate matter, PM, and volatile organic compounds, VOCs. These pollutants are known to have adverse effects on respiratory health, contributing to the onset and exacerbation of respiratory diseases such as asthma and chronic obstructive pulmonary disease, COPD. By developing engines with low CO2 emissions, the automotive industry aims to reduce not only the primary greenhouse gas responsible for climate change, but also the harmful pollutants that directly affect human health. Furthermore, the interest in low CO2 emissions arises from the need to achieve energy independence and reduce reliance on finite fossil fuel resources. The transportation sector heavily relies on petroleum-based fuels, which are finite and subject to price volatility due to geopolitical factors. Developing car engines that emit less CO2 promotes the adoption of alternative fuels and technologies, such as electric vehicles, EVs, hydrogen fuel cells, and biofuels. These alternatives offer the potential for greater energy efficiency and the use of renewable energy sources, reducing the dependence on fossil fuels and enhancing energy security. The push for low CO2 emissions in car engines is also driven by regulatory frameworks implemented by governments worldwide. Governments recognize the urgency of addressing climate change and have implemented various policies to encourage the development and adoption of low-emission vehicles. These policies include emissions standards, tax incentives, and subsidies for eco-friendly vehicles. By complying with these regulations and meeting the growing demand for sustainable transportation, automakers can ensure their competitiveness in the market and avoid potential penalties or reputational damage. Moreover, consumer demand plays a significant role in driving the interest in developing car engines with low CO2 emissions. Increasingly, consumers are becoming more environmentally conscious and prioritize sustainability in their purchasing decisions. As awareness of the impacts of climate change grows, consumers seek vehicles that align with their values and have minimal environmental footprints. Automakers recognize this shift in consumer preferences and are investing heavily in research and development to meet the demand for low-emission vehicles. By offering a range of options with low CO2 emissions, automakers can attract environmentally conscious consumers and gain a competitive edge in the market. The urgency to address the adverse effects of greenhouse gas emissions and transition to sustainable transportation solutions has prompted significant investments in research and development within the automotive industry. By reducing CO2 emissions from car engines, manufacturers can contribute to a more sustainable future, safeguard public health, and ensure the long-term viability of the transportation sector. Thanks for watching. While you're still here, click on the other videos you see on your screen right now